Okay, welcome back. I hope you got your development environment set up and you've got some simulation going. If not, you'll still have time to work on this after this. So we just wanted to go through the testing robot applications before you progress with the second part. Testing is important when it comes to software development, regardless of if it's a robot application or any other software that you develop. But when it comes to robot applications, it's important to do that, and especially in simulation, to reduce the life cycle, the time it takes to iterate over your code. And the reason for that is you don't have to package your code, deploy it to a robot, test it on the physical robots before validating your application. So simulation helps with that iteration and the quicker iteration and regression testing when it comes to developing robot applications. So when it comes to deciding on your test scenarios, especially in simulation, it's important to know what sort of fidelity is needed. So there are some test scenarios that you could do in a simulation with low simulation fidelity, but there are some that you need to have high simulation fidelity to be able to get valid test cases and results out of them. So an example on low simulation fidelity would be testing, for example, fleet management. So you don't need really high fidelity in your simulation to be able to validate your test in those scenarios. And then medium would be like behavior algorithm. So there, then you need some, it's a medium state simulation fidelity needed for those types of test scenarios. And then on the high simulation fidelity, for example, a vibration behavior, like you need high accuracy for those types of tests. So you want to make sure that your simulation is able to handle that level of detail and accuracy. So when it comes to defining your test cases, what we've seen is that they come into three categories. So navigation being one. So that's one of the things that you want to make sure your robot is able to operate correctly. And that's being able to, for example, to go through a narrow corridor, be able to navigate through real world conditions, right? Being able to avoid objects. So these are navigation categories when it comes to test cases. And then on the other side is like perception. Perception is another category when it comes to defining your test case. And perception is, for example, how does your robot behave when it comes to lighting variation? So how does your robot behave when there is environmental changes? When your robot is operating in the real world. So you want to make sure you're able to test for that, and your application and your robot can handle those variations. And then on the network and security side of things, you want to make sure that you're testing and validating your robot is able to handle network connectivity disruptions or any sensor noise that come through. So you want to make sure to be able to address those areas as well. An example of that is say for you're switching from Wi-Fi to LTE. What happens during that crossover? Is there a latency? How long does it take to do that? When it switches over, what happens? Are you losing any data as part of that, or is it able to handle it? So you want to make sure you're testing those kinds of scenarios when it comes to your robot applications. So as an example, here's a navigation test example. So this is a Python code. You've got access to this code as part of the workshop. So what this, it's a sample test case. What it does is it checks to see if the robot makes it to a goal, and that is if it gets to within a certain range of the goal. So I'll show you in the next slide. It's within 0.5 meters of the goal. obviously you can change that. So in this test case, what we're doing is we're defining what our metric is, which is the distance to goal. That's what we're trying to test against. And then you want to also have a timeout. Like if the robot's never going to reach your goal, you want to time it out. You don't want it to keep on going endlessly. So you want to have a timeout as well. So that's what that function on the bottom is, to check the timeout. And then here you can see that what the conditions are, that if the timeout hasn't happened, so it's still within the time frame, and also that the robot has reached within 0.5 meter of your target. Again, you can change that, and maybe that's something you can do in the workshop, make changes to the various scenarios in this test case, just to see what sort of different metrics you can get or different behaviors you can get. So this is a really simple test case. So as part of the workshop, you're going to run this test, and you can make changes to it if you like, and to see how it works and how you incorporate it in your application. But then as a, stretch goal, you can go ahead and define your own test case, write it, and run it again. That also depends on how much time you have. So yeah, we'll go ahead with the first part of it is to actually run this test case. So with that, let's go ahead and do the second part of the workshop, and that's to run these test cases and build your own if you have time. And for those that haven't got their simulation working, you can get that going first before you run these test cases. Again, we're here to help, so if you've got any questions, please don't hesitate to ask, and we've got a team to help you with that. So I'll come back when we at the wrap up, and thanks. Take care.